Over the weekend, I realized there are only about 50 days left until the next solar eclipse. Personally, I find this horrifying because I need to clean my house and yard before any of my friends arrive from out of state. I'm lucky. I live near the path of totality. I'm going to have to drive, but there are lots of really cool locations within about 3 hours in multiple directions, so I'm going to be able to avoid clouds. Maybe. I have bad luck. Anyways, not everyone is so lucky with their location, and a lot of sites are already starting to sell out. If you don't already have plans for the eclipse, it is time to start making them. You can no longer procrastinate. On April 8th, a solar eclipse, a total solar eclipse, is going to make its way across the United States from Mexico. This eclipse intersects the path of the 2017 eclipse in Carbondale, Illinois, and there's a fair chance that I will be doing a repeat of getting myself sunburned in Carbondale. While it may feel like solar eclipses happen all the time, because in recent years they kind of have, this lucky alignment of sun, moon, and North America isn't very common. And the next major eclipse to be seen by the majority of North America is in 2045. While I hope to still be alive at that point, I'm not betting on it. So I kind of see this eclipse as my last chance to see an eclipse without having to get on an airplane to fly to another continent. Pretty much everyone in the continental US will be able to see the sun in some sort of an eclipse on April 8th. You may see it looking like Pac-Man, you may see it looking like the thinnest crescent moon. But unless you're in exactly the right place, you will need to have solar eclipse glasses protecting your eyes throughout the entire event. And you won't be able to see the solar corona unless you see totality. I personally have never seen the solar corona. I've just seen a whole lot of clouds in a lot of different places. People I know with better luck say that seeing the corona is a life-changing experience. You see the sun as it's drawn by little kids with all the wavy bits flying away from its edges. Right now, pause this video and do this right now. You need to reserve time off at work. Figure out how you're going to see this eclipse and order protection for your eyeballs. You want to get solar glasses that have an ISO certification. If you go to eclipse.aas.org, they have great information. And if, like me, you have people coming to visit you because you live near totality, apparently it's time to start cleaning. In this episode, we're going to take a look at rocks in space, the small ones, the medium-sized ones, and the larger, but still mostly kind of small ones. It's a rocky start. We also have toilets in space, 2 rocket launches, and a closer look at galaxies at the beginning of the universe. This is Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. And if you want to keep getting science put in your brain, click that subscribe button. That way you'll get notified every time a new episode goes live. Our solar system contains a whole lot more than 8 planets, 2 former planets, and a star. There are myriad moons, asteroids, comets, weird neither comets nor asteroid things, and a whole bunch of small stuff. And when it comes to Earth protection, we sweat the small stuff. In recent years, a lot of effort has gone into both transforming new discoveries into precise predictions of possible impacts, and also into taking images from ground-based cameras and using them to pinpoint the actual impact sites that may have occurred. Much to my surprise, this has allowed researchers to find a meteor that impacted in the large Central Kalahari Game Reserve in Botswana, like in a place filled with rocks, dirt, animal dung, and the occasional animal that might want to eat you. They found a 3-centimeter remnant of what was once a 1 meter across meteoroid. Well, not much was in danger when the small rock hit a nature reserve in Botswana. The fear is always that something not so small will impact a region with a high population density. And in the early morning hours of January 21st, an also small rock streaked in over Europe, causing NASA to warn on social media, quote, "Heads up, a tiny asteroid will disintegrate as a harmless fireball west of Berlin near Nunhausen shortly after 1:32 a.m. Central European Time. Overseers will see it if it's clear." That streak got caught on cameras throughout Germany and as far away as Slovakia. This object, cataloged as 2024 BX1, was the 8th object detected before hitting the Earth. It was initially discovered by Hungarian astronomer Christian Sarnski 3 hours before impact, and subsequently it was tracked by NASA's Near-Earth Asteroid Scout and ESA's Meerkat Asteroid Guard Impact Hazard Assessment Systems. The combined observations from these facilities and others are what allowed that ever so accurate NASA warning to go out. Like the impactor in Botswana, the object that fell over Germany started out about 1 meter across and was reduced to palm-sized meteorites by the time it reached Earth. Somehow, and again, I don't understand by what magic researchers can do this, a fragment was found under leaves in a planted field. This meteorite doesn't look like the kinds of meteorites most of us have seen. It isn't a melty hunk of iron or a melty hunk of carbon-rich molecules. Instead, this is aubrite, a gray rock with white crystals that is coated with a clear, glassy melt. This is magnesium-rich. It's a kind of meteor that likely formed from magma in some kind of violent origin. This is actually a pretty rare kind of meteorite, and it's going to provide a rich set of data that will allow us to piece together its very rough orbit, its behavior through the atmosphere, and now the chemistry of the asteroid itself. This is essentially a free sample from space that saved us many millions of dollars while requiring some keen-eyed researchers to check under a bunch of leaves in a rainy German countryside. Sure, this sample is rather polluted by rain, dirt, humans, and whatever else lived in the dirt and plants, but it was free. In school, we learned all about the 8 planets. Pluto, the asteroid belt, and its larger members like OG former planet Ceres, and we learned about the comets. What your average kid's book omits are the random larger objects that hang out in the middle distances in our solar system. Around Jupiter's orbit, we have the Trojan asteroids. And out around Jupiter and Neptune and everywhere in between are transition objects called centaurs. Like asteroids, they can be a couple of 100 kilometers across. But unlike most asteroids, they seem to be primarily made of ices that can cause tails or other outbursts like we normally associate with comets. Among the centaurs of our solar system, orbiting between Saturn and Uranus, is a 250-kilometer across object wearing a pair of rings. These gossamer strands of material were discovered in 2013 when this object, Truog, and its rings were observed passing in front of a star. Researchers watching this event saw the star's light getting blocked by Truog, but also saw a pair of dips in the star's light that could only be explained by rings. Since then, the rings have been confirmed during subsequent occultations, and now researchers are left with a really cool discovery that is really hard to explain. In general, rings will spread out over time, but these rings are narrow. To try and understand how this is possible, researchers Amanda Sycophus and Mark C. Lewis ran a series of computer simulations that included rings with a variety of parameters, as well as the inclusion of a possible moon, if moon is the right word for a blob of ice and rock orbiting a bigger rock ice thing. They found that simulations with only the Centaur Truog and its rings couldn't maintain the narrow structures we see. But the addition of a 3-kilometer across companion would make this system stable. This size of an object is too small to see with current technology. But one day, maybe a mission to the outer solar system or significantly larger telescopes will make it possible to see if this paper's predictions are true. Oh, this work appears in the Planetary Science Journal. Before we end this segment, I want to alert you to a really cool paper about Saturn's icy moon Mimas. Published in Nature with first author Valerie Laney, this paper calls attention to Mimas's weird orbit that is changing over time in ways that just don't match how a solid object should behave. There is a lot of complex physics here, but it all kind of comes down to something called a moment of inertia. If you have a raw egg and a hard-boiled egg and you set them spinning side by side on the counter, they will spin very differently. Orbiting objects are more complex than objects like eggs or spinning tops that you can spin on your table. But it all comes down to the maths of what is the structure inside these objects? What is the density profile of the liquids and the solids? And when this team tried to work out the maths, the internal structure of Mimas, they discovered it had to include an ocean lurking tens of kilometers beneath the icy surface. What's more, this object isn't stable in ways you'd expect if it had been that way with an ocean since it formed. Instead, by looking at its motions and thermodynamics, they were able to work out that it has only had this ocean for about 5 to 15 million years. This paper has less than 2 pages of text, so they didn't have space to explain a lot of the details. And without giving you a grad class in physics, I'm not sure I could explain the details. But this is just cool. They were able to basically figure out that at some point after megafauna started walking the earth and before humans started wandering Africa, a new ocean formed inside a moon of Saturn. They aren't clear on how this happened. It wasn't caused by whatever created Mimas' signature crater. At least that option isn't listed in the paper. Most likely, the world had a close interaction with one or more of Saturn's other moons. And these interactions shifted Mimas into a more eccentric orbit and heated it up. So, if you want to see what can exist in an ocean that is only 5 to 50 million years old, Mimas has you covered. Up next, we take a closer look at galaxies in the early universe. Stay tuned. One of the unexpected realities of JWST is the discovery that we have really been asking entirely the wrong questions in a bunch of areas of astronomy. For instance, we generally asked, how did supermassive black holes and galaxies form, with a basic assumption that these things happened in some kind of an interrelated process? We thought stellar mass black holes came from stars, and sure, we thought there might have been tiny primordial black holes that evaporated away, but that was it. Case closed. Black holes formed with all the normal structures we experience today. At least that's what we thought. But JWST's observations require us to find a way to accelerate the formation of structures. And one way to do that is to seed the universe with black holes. As explained by study lead Joseph Silk, quote, "We know these monster black holes exist at the center of galaxies near our Milky Way. But the big surprise now is that they were present at the beginning of the universe as well, and were almost like building blocks or seeds for early galaxies. They really boosted everything, like gigantic amplifiers of star formation, which is a whole turnaround of what we thought possible before. So much so that this could completely shake up our understanding of how galaxies form." End quote. This work is published in the Astrophysical Journal Letters. Silk explains this far better than I possibly could, so I'm just going to read a little bit more of what he had to say. Quote, "We're arguing that black hole outflows crushed gas clouds, turning them into stars and greatly accelerating the rate of star formation. Otherwise, it's very hard to understand where these bright galaxies came from, because they're typically smaller in the early universe." End quote. This paper puts forward a new idea that seems to work, but this is just a start. It is still hoped that in the coming years, additional observations made with JWST will provide the data needed to make sure we're now asking the right questions. Not all discoveries require new telescopes. Sometimes they just require pointing old telescopes at new things. While the Hubble Space Telescope was launched in 1990 and was last upgraded in 2009, it is still producing spectacular images of things we haven't seen from it before. Newly published research on the galaxy AM 1054-325 shows us a galaxy that looks like it's been sprinkled with pixie dust. This is the result of two galaxies colliding and merging into something new, and in the process leaving behind tidal tails of star formation. This is just one of 12 merging systems with tidal tails that are discussed in a new paper in monthly notices of the Royal Astronomical Society. This is a paper led by Michael Roderick. Among these 12 systems, the research team was able to identify 425 star cluster candidates that appeared to be undergoing massive amounts of star formation, like 1 million blue newborn stars per cluster candidate, massive amounts of star formation. These clusters are going to allow researchers to piece together the story of how dust and gas is used up when galaxies collide, leaving behind a moment of glittering light and an eternity of fading away. These images also give us hints of what our galaxy's future may be. One day, 5 billion years from now, the Milky Way is going to collide with the Andromeda Galaxy to form a new Milkdromeda system. In the process, we too will form tails and glitter with star formation. This is our future. There are basically two ways to go digging for ancient relics in our universe. You can use a telescope like the JWST to look at the light from far-off objects. But our best systems can't tease too many details out of these distant objects. Alternatively, you can go looking for ancient stars that have managed to live undisrupted lives. In a new paper in the Astrophysical Journal, researchers led by Kristen used the JWST to look for the Methuselahs of stars. Here in our local group, toward the edge of our family of galaxies, is a dwarf galaxy that hasn't undergone many interactions and has stars of all ages, and I mean all ages. In this system are stars 13 billion years old, as well as stars still forming. As described by McQueen, quote, "In looking so deeply and seeing so clearly, we've been able to effectively go back in time. You're basically going on a kind of archaeological dig to find the very low-mass stars that were formed early in the history of the universe." End quote. By studying the distribution of stars in this galaxy, they were able to piece together a star formation history that ebbed and flowed over time. For the system and the universe's first 3 billion years, star formation raged. But then it ebbed away for a while before reigniting. According to Queen, quote, "The universe back then was really hot. We think the temperature of the universe ended up heating the gas in this galaxy and kind of turned off star formation for a while. The cool down period lasted a few billion years, and then star formation proceeded again." End quote. This way of studying a galaxy's history by looking at how many stars remain from different generations is the astronomy equivalent of counting tree rings. Here's to hoping that over time we're able to see results from a whole forest of galaxies and understand what effects plagued the universe and what effects were unique to each region of space. Up next, we have this week's Tales from the Launch Pad, as well as news of staffing layoffs at NASA's JPL. Stay tuned. Before we go to this week's rocket news, I want to take a moment to inform you about massive layoffs that have occurred at the NASA Jet Propulsion Lab at Caltech in Pasadena, California. Layoffs were announced February 6th and will affect 530 staff members, or about 8% of the JPL workforce. An additional 40 contractors were also affected. The cuts were made to both technical and support positions and are the direct result of budget cuts to programs such as Mars Sample Return and the failure of Congress to issue a new 2024 budget. As JPL Director Lori Leshin wrote in a memo to employees, quote, "Without an improved federal budget, including final allocation for Mars Sample Return fiscal year 2024 funding levels, NASA previously directed JPL to plan for a Mars Sample Return budget of $300 million. This is consistent with the low end of congressional markups of NASA's budget and a 63% decrease over the fiscal year 23 level. In response to this direction, and in an effort to protect our workforce, we implemented a hiring freeze, reduced Mars Sample Return contracts, and implemented cuts to burden budgets across the lab. Earlier this month, we further reduced spending by releasing some of our valued on-site contractors. Unfortunately, those actions alone are not enough for us to make it through the remainder of the fiscal year. So in the absence of an appropriation, and as much as we wish we didn't need to take this action, we must now move forward to protect against even deeper cuts later, were we to wait." End quote. There aren't 530 jobs available in space science that these people can apply for. These are people who in most cases will need to find work in other sectors of the economy. When they tell you as a kid, "You're smart, you should get a degree in science," it is with the knowledge that there aren't enough jobs for all of us, and our science skills allow us to get jobs in other fields, like working at the local grocery store. Back in the before times, fellow science communicator Dr. Stephen Grenade and I went to a Baltimore area Publix to grab sausages for a barbecue with other podcasters. While lost in the deli section, a nice guy about our age who worked there came up and asked if he could help us and ask what we were doing. We introduced ourselves as scientists and were ready with exciting info to share. But this nice guy, stocking coolers, told us how he too was a scientist, another PhD, who'd been working at NASA Goddard as a researcher until sequestration hit and budgets were cut. These are real outcomes. In fields like science, your success requires government funding. And our government has, through its inaction, made it harder for our nation to produce bright new discoveries. If you want to see more science, research the candidates in your district and vote for science in the next and every following election. Until then, if you have the time and energy, pick up the phone and make your voice be heard. Next up, I'm pleased to radically change topics. Normally, I would welcome on correspondent Erik, but this week you get me instead. He'll be back next week. Only one thing of note launched since our last show: the PACE mission for NASA from Cape Canaveral Space Force Station in the wee hours of the morning of February 8th atop a Falcon 9. Let's watch that launch.
5, 4, 3, 2, 1, ignition, engines full power, and liftoff of Falcon 9 carrying NASA PACE. Go Falcon, go NASA LSP.
Vehicle pitching downrange. Stage 1 propulsion is nominal.
PACE stands for Plankton Aerosols Climate Ocean Ecosystem. It has 3 instruments, a hyperspectral camera and 2 polarimeters. The latter will look at different types of dust, aerosols, and clouds, including smoke, pollutants, and ice crystals. They can measure the size, composition, quantity, and more about these particles. This will allow scientists to learn how clouds form and change over time. Studying aerosols will measure air quality and how much light is reflected back away from Earth. The latter is important because it's a measure of climate change and provides information about the Earth's energy balance, which is the balance between the energy the Earth receives from the sun and the energy the Earth loses back to space. PACE was launched south from Slick 40 on Cape Canaveral Space Force Base into a polar orbit. While many SpaceX missions have taken this trajectory, mostly Starlink and SpaceX's regular transporter missions, this is the first launch for NASA into a polar orbit from the Cape since 1958. The first stage completed its 4th flight and returned to Landing Zone 1 at Cape Canaveral. We track launches with the help of Rocket Launch Live. So far this year, the United States has launched 12 launches, China has had 8 launches, Iran has had 2 launches, India, Japan, New Zealand, and Russia have each had 1 launch. This makes the total number of launches so far this year 26. Finally, there are 9 toilets in space. In case you haven't noticed, we're tracking the number of toilets in space again. While some might think it's a waste of time to track such a crappy stat, it brings the team inner joy. We are, after all, 12-year-olds on the inside. It's also an indicator of just how far human flight has come and how different cultures deal with human waste. On April 12, 1961, Yuri Gagarin went around the Earth in style with a fully functioning waste disposal system. Not even a month later, Alan Shepard was forced to wet himself simply because the powers that be didn't think he'd be in a spaceship for hours on end. It didn't get better from there for the Americans. While Soviets had the relative comfort of essentially touch-free waste disposal, the Americans went to the moon with awkward, low-tech bathroom solutions, like sticking a bag to their rear end with the occasional turd escaping and floating around the spacecraft. True story. Americans didn't get proper sanitation solutions until Skylab, 12 years after the Soviets. And that was only while the crew was on board the station, not for the hours-long commute to get there. Now that you know the brief history of space toilets, on to the present, the current bathroom situation in space. If you ever need to tally the number of toilets in space, you're in luck, as it's a fairly simple formula. Number of toilets on the International Space Station plus the number of toilets on the Chinese space station plus the number of crewed spacecraft above the Kármán line. Right now, that's 4 on the ISS, 2 on the Tiangong, 1 on Crew Dragon Endurance, 1 on Soyuz MS-24, and 1 on Shenzhou 17, for a total of 9. An important thing to note: the number of toilets in space isn't the functional number of toilets in space. So if nature's calling, you need to be careful which toilet you head to. While the Crew Dragons are docked to the ISS, their toilet is inaccessible. And it's not much better on the Soyuz craft. Although technically accessible, their facilities are typically only used when the Soyuz is not docked to the ISS. We assume the same applies to the Shenzhou craft, since their design was derived from the Soyuz. So, if all the docked craft aren't an option when it's time for a bio break, surely any available toilet on one of the space stations is free to use, right? Well, it actually depends. If you're a Chinese taikonaut on the space station, as far as we know, the answer is yes. You can use whichever of the 2 toilets are available. But if you're an astronaut or cosmonaut on the International Space Station, emptying your tank can get a little tricky. If you're Russian, you have 2 toilets available for you to use, one in the Zvezda module and one in the Nauka module. And if you're American, you technically also have access to 2 toilets, but only one of them is actually usable. The newest toilet installed on the ISS, the Universal Waste Management System, is considered an experiment and was only used for 16 days before being forced into dormancy by a pressure sensor fault, which means that Americans are left with a single high-tech porcelain throne, the waste and hygiene compartment, where all the controls are labeled in Russian. Good luck, Anglophones. All right, that's it on toilets. Before we go, I have news of how a quasi-moon out near Venus got its name. Radiolab host Dr. Latif Nasser is responsible for an epic hunt for the source in a random children's poster for the identity of an object labeled Zoozie, Z-O-O-Z-V-E. Leveraging all the connections of a podcaster and a PhD from Harvard's History and Science department, he was able to eventually figure out that Venus has no moon like the Earth has a moon. There isn't anything specifically orbiting it. Instead, it has the first quasi-moon ever discovered. This 230-meter across space rock is on an orbit around the Sun that has it traveling along with Venus. Its orbit isn't exactly like Venus's, so over time it moves a bit ahead and a bit behind, passing round and round in a weird cashew-shaped pattern. Again, this is a quasi-moon. It is orbiting the Sun, not Venus. It just looks like it is orbiting Venus, if orbits could be cashew-shaped. And one day, one illustrator added this quasi-moon, which was cataloged as 2002 VE, to a picture of the solar system, a picture that ended up on Nasser's child's wall. And this illustrator's handwriting was somewhat indistinct. And a podcaster of science went down a rabbit hole of discovery because he thought the label said Zuzvi. On January 25th, this story was aired as part of that week's Radiolab episode. And a week later, on February 5th, 2024, the IAU's Working Group on Small Body Naming officially named the object Zuzvi. I have to say, I'm kind of glad the illustrator's confusing handwriting led to such a wonderful story. And that's it for now. Good night, everyone. And remember, go out and look up. Oh, and click subscribe.